Okay, this is 5.4. We're going to solve all of these using logarithms. Note that these can be used solving a graph. So feel free to use the graphing feature too if you'd like. So the way to solve logarithmic equations is you have a value, a number to a base to an exponent equals a value. And then you want to get it to that form, and then you want to put it in a log. So you say log base of the value, and then that solves it for the exponent. So we're going to type log base 16 of 84, and we're going to set it equal to 5x. So to get log base 16 of 84, you have two ways to do it. You can go down here and click on the keypad, functions, miscellaneous, log a. Then you can type in 16 and 84. Or you can type in the letters log, L-O-G, shift minus, 16, right arrow parentheses, 84. So that means 1.598. Is equal to 5x. So if you divide both sides by 5, that's your x value. So that number divided by 5 is about 0.3196. So x is 0.3196. You can plug that back in to check that it works, or use a graph as an intersection to verify your answer. All right, that's question 2. Question 3 is very similar to question 2. So let's set it up. You would say log base 4, 150 equals 8x. That's 3.6144. And then divide by 8. So 0.4518. So it says 2 decimal places, so 0.45 is good. All right, question 4. All right, 2 parentheses 3 to the x minus 15 equals 87. All right, in this problem here, we got to get rid of some numbers first. So we're going to add 15 to both sides. Always got to do what's being undone here first. So if you're subtracting 15, you got to add it. And if you're adding, you got to subtract. So that's going to be 2 parentheses 3 to the x power equals, that's going to be 102. Next, we're going to divide by 2. And that's going to give you 51. Check all these in your calculator if you need to. And finally, you can solve that in a log. So you say log base 3, 51, and that's equal to your exponent. So that's your variable. So let's put that in the calculator. So 3.5789. It says around 2 decimal places, so approximately 3.58. All right, next question. Three parentheses 4 to the 2x plus 5 equals 101. Okay, we want to minus this 5 out first. That'll give you 96. So 3 parentheses 4 to the 2x equals 96. Now we're going to divide both sides by 3. 30, 60, 90, 32, 64, 96. So that'll be 32. I'm just doing some mental math. Use your calculator if you need to. So that's going to be 32 Now we'll put it in the log. So log base 4, 32 equals 2x. So that's 2.5 exactly. So 2.5, and then we're going to divide that by 2. And what do you get when you divide 2.5 by 2? That should be 1.125. Or 1.25, excuse me. So 1.25 will be your answer. If at any point you're not sure if your answers are correct, use a graph intersection and or plug it in to get your see if your answer works for both sides. Okay, question 6. Okay, 8 to the 2x minus 9 equals 2397. This is already ready to be put in the log. You always put your exponent on the other side of the equation. Since we don't have anything added or subtracted or multiplied at the front, let's figure out what log base 8 of 2397 is. So we're looking at 3.74233. Okay, we're going to add 9. So that's 12.74233. And we're going to divide by 2. So that'd be like 6 point something. So let's see, 12.74233 divided by 2, 6.37. 6.371. So 6.371 is equal to x, because those will cancel out. All right, question 7. Okay, question 7's like 6. So another one of these, log base 5, 7105 is equal to 4x plus 6. So 5.5103. So minus 6, minus 6. Can't do that one in my head, so let's do the calculator on that. 5.5103 minus 6, negative 0.4897. Now we can divide by 4. Negative 0.122. Negative 0.122. 3 decimal places, so 122 is good enough, but make sure you have that negative in there. All right, now on to the word problems. And the second lesson, 5.2, we did some of these without knowledge of logs and using graphs. So now we're going to back it up with logs. So glass is filled with water. Every hour, 12% of the water evaporates from the glass, leaving you with this function. So 0.88, that's the 1 minus 0.12. And so we have our initial amount, initially has 500 milliliters of water. That's that first number there. And how long is it going to take for the glass to have 100? So this is going to be 100 down out there at the end. So we want to solve this equation. 100 equals 500, 0.88 to the t power. So we'll use logarithms. Start by dividing this initial number out. 100 out of 500 is 1/5. That's 20%. So that's 0.2. Use your calculator if you need to. And so now we're going to write it in log form. So our log form is going to look like this. It's going to be log. Your base is always the base of the exponent. Sometimes the base is on the right side, but that's the number that goes down there. And then in here, that's going to be what it equals to. So we're looking at 12.59. It says nearest tenth. So we'll say 12.6. So 12.6. Next question. Number 9, a population of bacteria grows according to the function PO 1.36 to the t power. Initial population, that's your PO, 1200. And your final population, how long is it take to exceed 1500? 15,000, that's your PT. So let's plug those in. And just do it like the last one. So we're going to divide by that 1200. Let's use our calculator. Is that right? 12.5. So 12.5 equals 1.36 to the t power. So it's going to be log base 1.36 of 12.5 equals t. So after about 8.21 years, we'll exceed 15,000. Says round to the nearest tenth, so we'll say approximately 8.2. Question 10. You have invested $1,000 into a savings account that grows at an average of 5.4%. So this is exponential growth. So 1,000 into a savings account that grows 1 plus r. Your r is 0.054. So 1.054. How many years would it take for this account to reach 1,600? So we want to know what t is so that it gives you your final result of 1,600. There's your setup. Divided by 1,000. That's going to be 1.6. And put it in the log. So 8.9367, nearest tenth. Again, I'll just say 8.9 is good enough. So it's approximately 8.9, but 8.94 would be better, 8.93 would be better, a little bit more accurate. Okay, one more question. In 1969, the Antique Club of America had 20,000 members. It grew at an average rate of 4.6% a year. So 0.046. It grew 1 plus your rate. How many years did it take for this membership to double? So in other words, become 40,000. So 40,000, 20,000, 1.046, and our unknown being t. So you'll see where that double comes into play. If you divide by 20,000, you'll get 2. So double would be 2, triple would be 3, etc. So you get 2 equals 1.046 to the t power. And log base 1.046 of 2 equals t. And that's 15.41. So we'll say 15.4. And that is it.